Hi students, a very good evening everyone. Welcome to the session and welcome once again to your favorite preparation platform for GATE engineering services and all technical examinations of the nations of your state as well, and that is the OHM Institute for Electronics and Electrical Engineering. I, Rakesh Sir, welcome all of you to this session. And yes guys, we have been having some concept booster sessions from the past few days, starting with signal and system. Okay, there will be many more concepts coming up in other subjects also. There will be concept classes coming up. So quickly, update all your friends that the session is now live and let's get started. And as you know, that today's content is going to be about periodic signals. Okay, an important area of signal and system. Okay, especially important once you go towards the Fourier series and all, and also important for direct question. And we will be dividing it into two different parts: continuous time periodic signals as well as the discrete time periodic signals. Okay. Coming up. So quickly, update all your. So yeah, just I checked the audio from my end. It looks good. Okay, you can also confirm me parallelly whether the audio and video is good for you. Come on, you can all update me if the audio and video is all good. Yes. Yes, quickly everybody all confirmed. Okay, all clear. If it is all clear, yeah, I get some updates. If it is clear, then it's good to go. Let me again test it. Yes dear, it's all clear only. Okay guys, so let's get moving ahead. Now time to get started with the class, time to get started with the concept. Okay, this is a brief intro about me. In case somebody doesn't know, they can go through it. Let's move forward and start periodic signals. And as I told you today, continuous time. Okay, the next session we will have it separately on the discrete time periodic signal, so that you learn both of them, so that you understand and conquer both of these individually. Okay, because there are some fundamental differences. The basic idea of a periodic signal remains to be same, but when it comes to computation, there are some differences, because we know in discrete time domain the time can only take integral values of time, and because of that there are some changes that you will be observing when you go to discrete time domain. Just a second. Okay. So periodicity, repetition, a signal whose value repeats, okay, whose nature repeats after every fixed interval of time will be known as a periodic signal, which repeats after a finite duration of time will be a periodic signal. Now that finite duration of time after which repetition occurs, like here, just taken randomly an example of something known as a half wave, something similar to a half wave sinusoid. Okay, so if this is a particular waveform, okay, if this is a particular waveform, you are able to see that at t equal to 1 second, okay, the similar waveform, the similar pattern with the same maximum amplitude repeats. Again at t, after 1 more second, that is at t equal to 2, again it repeats, and it is going to go up to the infinity. Okay, now such a signal whose value, whose nature keeps repeating, okay, from minus infinity to the infinity after every fixed interval of time. So like, what is the fixed interval of time here? What is that fixed interval of time you are able to see here? Here it's that fixed interval of time which is equal to 1, because here the repetition is occurring after every 1 unit of time, and that fixed interval of time, that minimum value of time, will be known as the period of the signal. Okay, now the value of the signal repeats after 1 second, it also repeats after 2 seconds, it also repeats after 3 seconds. So what is my period? Is it equal to 1 or 2 or 3? So basically period could be any of these things. Okay, period simply means a finite value of time after which repetition occurs. Okay, so at whatever is at t equal to 0, same is at t equal to 2. So period is 2 also. That is why normally we call the period as the fundamental period. Now what is the fundamental period? Is the minimum value of time after which repetition is going to occur. It is the minimum value of time after which the repetition is going to occur. Okay, so now here you see an example of, just let me make a correction, it's a sinusoidal wave but to be taken from minus infinity to the plus infinity. To be considered from the minus infinity to the plus infinity, right? Okay. So this is a very simple waveform which we all know as the sinusoid. Okay, A sine omega t. Okay, and what is the time period? You all know it's, okay, if you see with respect to this waveform, okay, see, maybe you can mark this as the time period, it's all up to you. Okay, this is one time period because this is where the positive cycle starts. Okay, there is a positive cycle, let me highlight this separately. What is that one period? There is a positive cycle, it reaches the peak value known as the amplitude, then it falls, and then there is a negative cycle, and again the value is going to become 0 after a certain amount of time. Okay, and eventually then again the same positive cycle repeating, and this is what is known as the time period. Okay, now time period could be measured anywhere, from anywhere. Okay, the time, okay, between any two similar points, okay, can be marked as time period. So like here, okay, this is one maxima to the next maxima. Okay, this is one maxima to the another consecutive next maxima. This is also known as the time period. Okay, so time period for periodic or for a sinusoidal waveform, I hope you are aware, it is 2 pi by omega. It's a very simple calculation if you want to understand also. Okay, how we can simply write it? We can simply understand by the concept of sine theta, because sine theta plus 2 pi is known as the sine theta. Sine of theta plus 2 pi is what is known as the sine theta. Correct? Sine theta plus 2 pi is the sine theta, because the value of sine theta repeats after every 360 degree, after every 2 pi. Okay, now if sine theta plus 2 pi is sine theta, okay, and here I have taken sine omega t, okay, a sine, forget a is the amplitude, let me only consider the theta as omega t here. So we know that sine omega t plus 2 pi should be equal to sine omega t. Okay, now that means sine of, okay, let me take omega common. So I get t plus 2 pi by omega. If I take omega outside, so here with 2 pi I have to divide the omega, and this is equal to sine omega t. Okay, right, now if I multiply both the sides by a, if you multiply both the sides by a, be it any amplitude, okay, if I multiply a here, if I multiply a here, so what is this right hand side here? The right hand side is the xt, the original signal taken. And what is this way? What is this on the left hand side? It is x of t plus, see here if it is a sine omega t, here it is a sine omega t plus something. Rest of the nature is same, t plus something. What is that something? Okay, 2 pi by omega. Okay, 2 pi by omega, and hence this is what is known as the time period. Okay, time period, that is 2 pi by omega. Okay, so officially, as I already told you, if t is the period, then 2t, 3t, etc., any multiple of time period will be also a period, so that the minimum value of the time t after which repetition occurs is the fundamental period. Okay, will be known as the fundamental period. Okay, that means, putting down in simple words, if you look into the first basic waveform only, okay, whatever is the value of the signal xt should be same as the value of the signal at xt plus t or xt minus t. Okay, t plus t means left shift. So whether you go 1 unit left or whether you go 1 unit right, here the time period was 1. So whether you go 1 unit left or 1 unit right, you get a similar value. Okay, whether you go 2 unit left or 2 unit right, you get the similar waveform. Okay, so xt plus minus 2t, it is also equal to x of t plus minus 3t, etc., 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 etc. Okay, or in general I can simply write that the xt can be written as x of t plus minus nt. If the value repeats after t, it will repeat at 2t also, 3t also, 4t also. Okay, any of them can be known as period, but the fundamental period will be known as the smallest value of time at which repetition occurs. Like here it is equal to 1. Okay, now for sinusoids you were all aware, but in case, just to complete the notes, let me also write down that whenever you have any sinusoid, whether it is a sine omega t or a cos omega t, what's going to be the period? the time period is simply 2 pi by omega, where omega is the fundamental frequency. Okay, the reciprocal of the time period, basic time period, will be known as the fundamental, okay, frequency. Okay, in hertz. Okay, if you just take it with 1 by t, that is in hertz. Okay, the frequency 1 by t, and this is the angular frequency 2 pi by t, and that is what is measured in radian per second. Okay, already I told you for signal to be periodic, it should be periodic from minus infinity to the plus infinity. I discussed that earlier only. Okay, so like, you know, this is what is a rectangular square waveform. Oh, sorry, a periodic square waveform. Okay, a periodic square waveform. Square ho sakta hai, rectangle ho sakta hai, anything. So what is the time period? As I told you, time period you can measure, okay, between any 2 points, okay, whose nature looks to be similar. Like if I take these 2 points here, okay, t equal to 0, t equal to 2. What is the similarity? These two are the centers of the consecutive rectangle. So what is repeating here is the rectangle repeating here. Okay, so the time period is equal to 2. Or somebody can measure from the starting of the rectangle minus 0.5 up to plus 1.5. What is the time gap? It is t equal to 2. It is t equal to 2. Okay. So now whenever I say period, I told you that t, 2t, 3t, 4t, all of this is period. But now whenever I say period, by default I will mean fundamental period. By default I will mean only t, single t. Clear? Okay. So like here again, if you take t equal to 0 and t equal to 3, okay, this is what is the center of this decreasing line of the triangle also you can place, and sorry, up to here, from this 0 up to the 3, this is equal to the time period. Or if you want, you can measure from the beginning, the spike, okay, up to the next spike, positive spike, this is the next positive spike, minus 1 to 2, how much is the gap? Still 3. So from between any two, you know, similar looking points, you can measure the time period. This is a sawtooth waveform. Okay, very important, you know, once you go to the power discussions, the sawtooth waveform. Okay, this is one center, this is the next center, and the time period would be 2. Okay. So something very basic, find the fundamental period and the fundamental frequency. So what is the time period? Okay, now fundamental frequency, if I want to talk in terms of omega angular frequency. Okay, so this is sine omega t. Okay, so it is 2 pi by 3, the omega is 2 pi by 3. Okay, if I want to talk in terms of time period, omega is also equal to 2 pi f. So if you want to write down f, so that is 1 by 3 hertz. This one is in radian per second. Okay, and the fundamental period is what is known as 2 pi by omega. So that is 2 pi upon 2 pi by 3, and that is equal to 3. Okay, the time being measured in seconds by default, the SI unit. The time period is equal to the 3. Okay. Chalo. What about the fundamental period of the signal? xt is equal to j e power j 10t. The signal j e raised to the power j 10t. Just a second. So we can be logical enough. We know what is e power j theta, and if we know the expansion of e power j theta, because this number j is just a complex constant, it will just change the phase of the signal. Okay, but it is not a function of time, it is a complex constant value. Okay, so whenever you have the signal, dear, okay, in general, okay, a e raised to the power j omega t. Let me write it in the form of e power j omega t. Okay, yeah, it may have some phase as well. Okay, a e power j omega t plus phi. A e power j omega t plus phi. Okay, this is also, now e power j theta is cos theta plus j sin theta. Okay, so whatever is the period of the cosine and sine, similar will be copied here. Okay, if you want to see once again, the time period here will be 2 pi by omega. Why? Because whenever I add 2 pi by omega, whenever I do xt plus t, it should be equal to xt, na? It should be equal to the xt. So very simple calculation, a e power j. Now what is omega into t? Okay, t is now replaced as t plus 2 pi by omega. Okay, so this is going to a e power j omega t. This is separate. Okay, plus phi. Let me take the plus phi here. Okay, and then omega cancel, plus 2 pi. Plus 2 pi I have written at the last. Now this is a e power j omega t plus phi. Okay, into e power j2 pi. I have separated this e power j2 pi. Okay, and here, what is the e power j2 pi? Okay, that is known as how much? E power j2 pi is known as the cos theta plus j sin theta. e power j theta is always the cos theta plus j sin theta, and the value of cos 2 pi is 1, the value of sin 2 pi is 0, and the hence answer is equal to 1. The e power j 2 pi is equal to 1. The value of e power j 2 pi is equal to the 1. Done? That is equal to 1. Okay, e power j 2 pi. Done. So if this e power j 2 pi is just equal to 1, so you are only left with a e power j omega t plus phi, and that is back to your signal xt. So xt plus t equal to xt, and hence this value is known as the time period. This value is known as the time period, that is 2 pi by omega. And I have told you logically why, because e power j theta is cos theta plus j sin theta. So whatever is the period, okay, for cosine and sine, which is for both 2 pi by omega, same should be for this complex exponential signal, that is 2 pi by omega. Okay, so here, this is of the form, okay, omega equal to 10. Here the omega is 10 and the time period is equal to 2 pi by 10, or that is equal to pi by 5. The time period of this is pi by 5. Okay. All right. Okay. Let's move ahead to the next. A fundamental question. Okay. Is the signal cos 5t ut periodic? Just asking. If it is periodic, tell me the period as well. Okay. Cos 5t ut, is it a periodic signal? Cos 5t ut, is this a periodic signal? Is this a periodic signal? So now see, if it was only cos 5t, we all know, I just told you that cos omega t or sin omega t, they are always periodic with period 2 pi by omega. Okay. So I was telling you in the beginning that, you know, once you go to discrete time, there will be some differences. So yes, that's what you will feel the differences later on. Ki in the discrete time domain, a sin omega n or a cos omega n, they will not be always periodic. Okay, there are some reasons behind it that we will learn in the next class. So I'm telling you discussions on discrete time domain on a separate basis we are going to have. But right now, this is not cos 5t, it is cos 5t into ut. So what is the waveform for this? Okay, ut. We all know that ut, unit step signal, ut equal to 1 for what? Ut equal to 1 for t greater than equal to 0. What happened? Just a second. Now it's fine. Ut equal to 1 for t greater than equal to 0, and it is equal to 0 for t less than 0. Okay, that means when you want to write down the signal xt given here, cos 5t into ut. So it will be cos 5t and ut will be 1 if t is positive. Okay, but if t is negative, okay, cos 5t into 0 will be 0. So here you get a cosine waveform, a sinusoid waveform, which is going to exist only for the positive value of time, which is only right sided, which will only exist for the positive value of time. Okay, so normally this is what is the cosine waveform you have seen. Okay, but in this case the cosine waveform will only exist for t greater than equal to 0, and on the left hand side, here on the left hand side it's 0, and this is what is the cosine waveform then going to exist. Okay, right, having the amplitude 1 unit, the magnitude a is 1. Okay, and the time there is no time period actually. So question is, okay, will it be periodic? Of course, for t greater than 0, if I specify it is periodic, Ramji, that is correct. But in general, is it overall periodic? When I say periodic means is it overall periodic, and for a signal to be periodic, when I say only periodic means overall periodic, for a signal to be periodic, okay, it must exist from minus infinity to plus infinity, something I already told you. It must always exist from minus infinity to the plus infinity for a signal to be periodic. So overall this is not periodic. Overall this is not periodic. Okay, this waveform is not periodic. And the waveform and the signal which is not periodic, we call it as what? We call it as aperiodic signal. We call it as a aperiodic signal. At the same time, there is a special name given to it. What is a special name? Okay, it is periodic only for t greater than 0. Okay, it is periodic. Overall, it is, if I talk about overall it is not periodic. Okay, but this particular signal cos 5t ut, here, this particular signal, okay, is periodic. Not overall periodic, I accept, but it is periodic. Okay, only for t greater than 0. Only for t greater than 0. Whenever a signal is periodic for t greater than 0, okay, it is also known as a switched periodic signal. It is also known as a switched periodic signal. It is also classified, it is also known as a switched periodic signal. It is also known as a switched periodic signal. Okay, switched periodic signal. Clear, everybody? This is known as a switched periodic signal. Okay, done. Let's move ahead to the next. Okay. Chalo. Let's go ahead to the next then. Find the fundamental period and fundamental frequency of this signal. Okay, even part of cos 2 pi t ut. Now, just now I told you cos theta, cos omega t is periodic, but cos omega t ut is overall not periodic. Okay, there is a signal even part of cos 2 pi t ut. This is a good question. Okay, now what is this even part of cos 2 pi t ut? What is this even part of cos 2 pi t ut? What should be this even part of the cos 2 pi t ut? Say, dear, first of all, given any signal, what is the even part of a signal? Given any signal, what is the even part of a signal? The even part of any signal, also we call it as xct, just as a quick revision, is known as xt plus x of minus t divided by 2. Okay, what is the odd part of a signal? What is the odd part of any signal? Odd part of any signal, xot, is what is known as the xt minus x minus t by 2. Okay. Whenever you check this part, xct, it will be even symmetric. Xc minus t will be always equal to xct. The part xot will always be odd symmetric. Xo minus t will be equal to minus of xot. And when you add both these parts, okay, you get the signal xt. Yeah, I can say that signal xt can be written as xct plus xot. Any signal can be broken into two parts, decomposed into two parts, one of which is even, one of which is odd symmetric. Okay. Now, there is a question, even part of some value, okay, and we have to say whether it is periodic, and if it is periodic, then you can tell the period and the frequency. Okay, so let's take this. Okay, so what is the signal xt here? The signal xt is known as even part of cos 2 pi t ut. Okay, now what is this even part of cos 2 pi t ut? Okay, let's write down. It is equal to the signal xt itself, cos 2 pi t ut, plus x minus t, so cos minus 2 pi t u of minus t. Okay, completely t replaced by minus t and whole divided by 2. Okay, now dear, this is cos 2 pi t ut. Now come to the next part. We all know what is cos minus theta. Cos theta is a even symmetric function. Cos minus theta is always equal to cos theta. So cos minus 2 pi t is equal to the cos 2 pi t. Okay, and then u of minus t. Okay, further whole divided by 2. Okay, and then what is the xt is known as cos of 2 pi t. Okay, what is the xt is known as cos of 2 pi t. That can be taken common. You are left with ut plus u minus t. Okay, and then whole divide by 2. What is ut plus u minus t? Dear, what is ut plus u minus t? The ut plus u minus t is equal to 1. The ut plus u minus t is nothing but equal to 1. So you get 1 by 2 cos 2 pi t. So dear, very simple, na? If there is any confusion, chalo. Yes. If there is any confusion, just have a look. Just okay. So we all know what is ut. Okay, and u minus t we all know is the mirror image, time folding case. Okay, mirror image or the time folding case, I can say. Okay, so ut equal to 1 for t greater than equal to 0. Okay, u minus t equal to the mirror image of this. Okay, that will be equal to 1 for t less than equal to 0. The value remains to be same, but this is right sided, so mirror image, this comes to be left sided. When you superimpose both the waveforms, so now when you superimpose both the waveforms, let me draw two graphs here. So dear, when I am going to draw ut plus u minus t, so when you superimpose, add the waveform, so it is one for left hand side, one for right hand side, that means it is a flat one. The ut plus u minus t is always fixed 1. Okay, that is what is the point I have used here. Ut plus u minus t is equal to the 1. Okay, it's in case if you subtract these two waveforms, subtract means with the order first ut minus u minus t. So if I subtract, see, let us do, region by region. If you talk about right side, for t greater than 0, you have 1 minus 0. 1 minus 0 is 1. 1 minus 0 is simply equal to the 1. So it will be 1 here. Okay. When you subtract on the left side, so it is 0 minus 1. This is 1, but the above one is 0. So when you subtract 0 minus 1, that's negative 1. Okay, that's negative 1. So this is what you get on the left hand side. That is negative 1, and here it is equal to plus 1. And what is this waveform, if you are aware? Okay, although our class today is on periodic signal, but just some values we can add on. If you are aware, this is what is known as the signum function. This is what is actually known as the signum function. Okay, which is equal to 1 for positive value of time, which is equal to minus 1 for the negative values of time. This is what is the signum function. Okay. Chalo, yeah. Eventually, let's come back to the previous question. So, what is the xt you have got for the previous question? Okay, it is of the form half, okay, cos 2 pi t, a sin omega t, whatever be the amplitude is not going to affect the time period. The time period only depends on the frequency. Okay, so what is the time period? That is 2 pi by omega. Omega is also 2 pi, and the time period of this waveform is 1. If it is periodic, we can always say the time period. Fundamental frequency, angular frequency, it's 2 pi. Very clear. Done hai. Chalo. Now similarly, if there is a signal, even part of sin 2 pi t ut, what is the fundamental period and the frequency? Okay, if it is sin 2 pi t ut, chalo, let's check that out. If it is sin 2 pi t ut, if it is equal to the sin 2 pi t ut, even part of sin 2 pi t ut, even part of sin 2 pi t ut. Let's see that. Okay, let us see that. So what is that even part again? Okay, what is that even part? What is the signal xt? Even part of the sin 2 pi t ut. Okay, that means first take sin 2 pi t ut, then add sin minus 2 pi t, xt plus x minus t. So sin minus 2 pi t u minus t and whole divided by 2. That is the even part formula. That is what is the even part formula. Okay, now this is equal to sin 2 pi t ut sin minus theta. Sin theta is an odd function. Sin minus theta is always minus sin theta. So now this time we will get minus sin 2 pi t into u minus t, okay, whole divided by 2. Okay, once again I can take the sin 2 pi t common, okay, and then I am left with ut minus u minus t, okay, by 2. Now ut plus u minus t, that was a fixed value 1. Ut minus u minus t does not have a fixed value, it has to be broken and seen. Okay, like that means let me break this graph and draw for you. Okay, sin 2 pi t ut. Chalo, let us draw this graph. What is this graph actually? What is this graph actually? So before I draw that graph, okay, let me here first draw, okay, the sine, how much is the value? 2 pi t. If it was only sine 2 pi t, dear, if it is only sine 2 pi t, this is how the waveform is. This one is definitely periodic. This one is definitely periodic. This is sine 2 pi t ut. This is sine 2 pi t ut. Okay. Then here I want to draw something else. What I want to draw here in the given question is, just have a look into it here. Okay, in the given question, my question is sine 2 pi t ut and then minus sine 2 pi t u minus t. Minus sine 2 pi t u minus t. That is what is the given signal. So sine 2 pi t into ut. Ut will be there for right side. Whenever t greater than 0, ut will be 1. Sine 2 pi t into 1, sine 2 pi t waveform. Whatever is the actual sine waveform, just copy it. Okay. Now dear, u minus t will exist. U minus t will exist only for left hand side. We have a look into this. U minus t equal to 1 only for t less than 0. Okay, so dear, whenever t less than 0, then only this part will exist and it is minus sine theta. See, if this is sine theta, okay, on the left hand side, this is the sine theta, dear. Okay, so now you have to take minus sine theta. Minus means all the amplitudes will reverse. This amplitude which was negative will go to positive. Which was positive, that will go to negative, something of this kind. This is the waveform that is actually going to come in front of you. Now tell me, is it periodic? Now tell me, is it actually periodic? The periodicity has been lost. Let's say this is one positive cycle. Okay, it repeats. So if a positive cycle repeats, it should continuously repeat. There is a positive cycle, then suddenly a negative cycle. Okay, so there is no pattern into which a complete repetition is seen. Okay, overall I will call it as aperiodic. Any doubt, please ask me. This signal is not periodic, it is aperiodic, and hence the question itself is invalid. There is no frequency and there is no time period. Just to test your concepts, I started the question, find the period, but actually it is aperiodic. Actually it is aperiodic. There cannot be any period and the frequency for this. Clear, everybody? Any confusions, please do ask me. Okay. For periodicity, I told you it should have the similar pattern from minus infinity to the plus infinity. Okay. Chalo. Let's move ahead to the next step. If this is clear, let us move ahead to the next. Chalo, yes, next, very important point. What about addition of periodic signals? Okay, when you add periodic signals, okay, so suppose I take a signal x1t, okay, understand, which is periodic, okay, which is periodic, and if it is periodic, it will have some period, and suppose the value of the period is t1. I take another signal x2t, which is also periodic, having the period t2, which is also periodic, having the period t2, correct, having the period t2. Okay, now let there be another signal xt, which is x1t plus x2t. When you add these two signals, so x1 and x2 are confirmed periodic, I am telling you. Okay, but when you add two periodic signal, will the result be always periodic? Will the result be always periodic? Let's have a look into it. Let's have a look into it. Okay. So, is this periodic or not, or aperiodic? Chalo. So, now, because the signal x1t is periodic with period t1, so I can say that, dear, x1t is equal to x1t plus t1. Okay, the value of the signal repeats after t1. Okay, or it repeats after 2t1, 3t1. So in general, we have written that it repeats, suppose, after mt1, after every integral multiple of t1. Okay, similarly, okay, x2t, because it is periodic, it can be written as x2 of t plus nt2, x2 of t plus nt2. Okay, chalo, this is what is x2t. Okay, now if xt is periodic, okay, I don't know it is periodic or not, but if it is periodic, okay, then xt should also be equal to x of t plus t, where t will be the time period. If it is periodic, it will have some time period t, okay, such that xt equal to x of t plus t. Okay, so if this is true, then the signal will be periodic. Okay, let us test that. Let us test xt is equal to x of t plus t, whether this is correct or not. Okay, so chalo, what is xt? It is x1t plus x2t. So what is going to be x of t plus t? what is going to be x of t plus t? That will be equal to how much? Okay, everywhere replace t as t plus t. ठीक है, इसको थोड़ा सा मैं right shift करके लिखूंगा. Let me just start it from here. X of t plus t. So x of t plus t. Here also write down t plus t. So x1 t plus t. Okay, and here also you will write down t plus t. So x2 of t plus t. Okay, now what is this equal to? xt is x1t plus x2t, but x1 and x2 are both periodic. x1 and x2 are both periodic, so we can use this definition of periodic signals. So x1t is equal to x1 of t plus mt1. Similarly, x2t is equal to x2 of t plus nt2. Correct? Now, if these two are equal, what I am trying to tell you is xt should be equal to x of t plus t. Okay, if this is true, then the signal is periodic. Okay, so for xt equal to x of t plus t, what is the condition that we have to match? That the time period t should be mt1 and it should also be equal to nt2. The time period t, okay, time period t is the time period for the signal xt, for the combined signal xt. So it should be mt1, it should also be equal to nt2, means it should be multiple of both t1 and t2. It should be multiple of both t1 and t2. Now for this to be true, have a look into this second and third. Okay, we have mt1 eventually equal to nt2. So we have t1 divided by t2. We have t1 divided by t2 equal to n by m. t1 divided by t2 equal to n by m. What does it mean? t1 by t2 equal to n by m, where n and m are integers. Okay, because the period of a signal is t or 2t or 3t. It repeats after every integral multiple of the time period. Na? Okay, so what is m and what is n? M and n are always integers. Okay, they are always integers. Okay, so t1 by t2 is n by m, ratio of integers. And what is the ratio of integers known as? The quantity which is known as rational number. Okay, so if this is correct, if I say xt equal to x of t plus t, that means if I say xt has to be periodic, that is only possible if t1 by t2 is a rational number. If the ratio of the time periods, okay, is a ratio of two integers, again, ratio of integers is a rational number. Okay, then what is the final time period? Okay, if it is periodic, this is the test finally. If it is periodic, then t1 by t2 should be ratio of integers, and then the time period is mt1 or nt2. Means just cross multiply here. Okay, or cross multiply here. We will learn with question. Okay, mt1 or nt2. Okay, or you can directly take LCM. See, what is this theory? Time period is a multiple of t1 as well as multiple of t2. That means this time period is the common multiple. This time period is known as the common multiple of t1 and t2. Okay. There can be many common multiples of t1 and t2, but for fundamental time period, you need the minimum value of time after which repetition occurs. So you have to consider the lowest common multiple. That is LCM. Lowest common multiple. That is the LTM. Okay, so that is what is the complete summary put here. x1t plus x2t. Okay, a signal xt is a linear combination of two periodic signals. Now, when I say linear combination, I mean the signal xt could be of this form. Okay, ax1t plus or minus, even minus also, okay, plus bx2t. I have taken simple case x1t plus x2t to explain you, but if it is any linear combination, 3x1t plus 5x2t, so then also same test you have to check. Even for subtraction, same test you have to check. What is the test? Okay, this is periodic if t1 by t2 is a rational number. The rational number means ratio of two integers. Okay. And if it is periodic, there has to be period. What is the period? The period is equal to mt1. See, I told you, cross multiply. mt1 or nt2. Any of the cross multiplication you can take. Okay, cross multiply. The ratio you have got, just cross multiply. Okay. Or it is simply the LCM, as I already explained you. Okay, it can also be taken as LCM of t1, t2. If it is three signals, LCM of t1, t2, t3, etc. Okay, so now have a look into this question. There are two continuous time signals given to you, x1t and x2t. Okay, x1t and x2t, 6 sin 8 pi t plus 14 cos 6 pi t, and x2t is 6 sin 8 pi t plus 14 cos 20 t. Which of the following statement regarding the periodicity of the signals is true? Regarding the periodicity of the signals is true. Chalo, let's have a look into it. x1t and x2t are two signals given to you, 6 sin 8 pi t plus 14 cos 6 pi t. Chalo. Let's check both. Okay, x1t periodic, x2t aperiodic, yeah, both are periodic, both aperiodic, x1 aperiodic, x2 aperiodic. Which of the option is correct? Chalo. So let's try for the first one. Okay, for the first one. Okay, let's try for the first one. Okay, that is x1t. Okay, now what is the first time period? T1. Okay, time period for sinusoid is 2 pi by omega, 2 pi by 8 pi, which is 1 by 4. Okay, what is the value of T2? 2 pi by 6 pi. For cos omega t also it is again what? 2 pi by omega. So this is 2 pi by 6 pi, 1 by 3. Now dear, what is T1 upon T2? That is 1 by 4 upon 1 by 3. That is equal to 3 by 4. Is it a rational number? Any number expressed in the ratio of two integers is a rational number. So yes, this is rational. So the given signal is periodic. X1t is periodic. Okay. So X1t is periodic. Acha. Although they are not asking the period. But if they ask, what is the period then? Okay. What is the period then? Okay, as I told you, T1 by T2, look into the final ratio, 3 by 4. 3 by 4. So it is 4T1. Cross multiply 4 with T1 or 3 with T2. Both are the equal answers. You try any product. Okay, so like T1 is 1 by 4. So 4T1 is 1. Yeah, T2 is 1 by 3. So 3 into T2 will be 1. From both you will get the same answer only. Okay. So answer is 1. Okay. T1 is 1. Or you can also say, okay, what is that T1? Okay, LCM of 1 by 4 and 1 by 3, which will be 1. Okay, LCM of fractions you can calculate. Okay. Let's not spend time there, but okay, done. That you can calculate. Chalo. Let's move ahead to the next. Next is the X2T. Okay, now second X2T. Okay, let's do it here. The second signal. X2T, whether this is periodic or aperiodic, we will put the comments. Okay, what is the time period T1? Now there in this 6 sine 8 pi the same. Okay, so 2 pi upon 8 pi, that is 1 by 4. Second time period. Okay, you have 14 cos 20t, 2 pi by 20, or that is also known as pi by 10. 2 pi by 20 also known as the pi by 10. Okay, so now what is the ratio T1 upon T2? 1 by 4 divided by pi by 10. Okay, so that is equal to 10 divided by 4 pi, or if you cancel to 5 upon 2 pi. But is it a rational number? Pi. Point here is there is a pi struck. Is pi a rational number? Okay, some of the students mislead and say yes, pi equal to 22 by 7 and hence this can be taken as a rational number. But no dear, pi is 22 by 7 is the approximate value of pi. It is not the perfect value of pi. They match up to 3 to 4 decimal places. They will not match for all decimal places. Okay. Okay, so pi equal to 22 by 7 is just an approximation, not the true value. Okay, it is not the true value. Okay, hence, okay, always pi is considered as an irrational number. Its exact value can never be expressed as ratio of two integers. Okay, and hence the result that overall I have got here is irrational. And if T1 by T2 is an irrational quantity, then these two, when these two signals are added, the resultant will be aperiodic. Individually, this is periodic. Cos 20t, periodic. But when you add them x2t, this is aperiodic. Okay. So what about x2t? This is aperiodic. So addition of two periodic signals may not be always periodic. Correct answer is option number A here. I repeat, addition of two periodic signals may not be always periodic. Okay, and because it is aperiodic, so I am not calculating period. There is no period for this eventually. Okay, chalo. If this is clear, you can attempt the next question here. Chalo, tell me. If this part is clear, please attempt and do tell me the next answer. Okay, so we have to match the following. We just have to match the column here. Let's complete F1 and F3 here. What is the time period for F1? Okay, sine 2 pi by 3. Okay, we have to match the period to 2 pi upon 2 pi by 3. Okay, let me do it here. Right. So what is this time period? 2 pi divided by omega, 2 pi by 3. So this is equal to 3. Okay, that is, this goes with 2. This goes with statement number 2 in the list 2. Okay, F3t, what is the time period? What is the time period? 2 pi by 3. Okay, 2 pi by 3. Okay, that is fourth one. That is fourth one. The first and third was simple. Okay, the first and third is simple. Okay, now, okay, second and fourth. Fourth is very clear, linear combination. Whether addition or subtraction, there is a linear combination, f1 minus 2 f3. Let's try this one. This is something we have taught. Then we will come to product here. There is f2, which is product of two sinusoids, product of two periodic signals, especially sinusoids. How will you deal with that? उस पे भी आ जाएंगे. First, let us come to f4t. That is f1t minus 2 f3t. f1 3 minus 2 f3t. Okay, now this has the time period t1. This has the time period t1, which is equal to 3. This has the time period t3. Let me call it as t3, third signal, and its time period is 2 pi by 3. Its time period is 2 pi by 3. Okay. Correct. Now, what is t1 upon t3? What is the ratio of their time period? 3 divide by 2 pi by 3. 3 goes above, 9 upon 2 pi, but a pi is left. So irrational. And hence the given signal, the fourth one, is aperiodic. Hence proved. Okay. Fourth one is aperiodic. Okay. Aperiodic here in the list 2 is option number 3. So it will match with 3. By this time you can match the answers. Okay. I think maybe before this sometimes P goes with 2. Oh, sometimes you are lucky. Sometimes, not every time, but sometimes you are lucky. Just like first calculation, the time period of first is 3 and P matches with 2. P matches with 2 only in the option number D. Sometimes you don't have to do anything else. Answer is D. Then don't check others. MCQ question, if you have matched the answer, don't check other. It is not conventional question where you have to explain everything. So it is D. But here, right now, my intent is to explain you each and everything. So let us come to the S also done. Let us come to the Q, F2T. Now let us come to the next signal, F2T here. Let's take it separately. F2T. What is the F2T? It is product of two sinusoids, sine 2 pi by 5t. Sine 2 pi by 5t multiplied by cos 4 pi by 3t. Cos 4 pi by 3t. This also you must be able to do. Okay. Now you just have to use one identity here to solve the problem. Simply, what is this? It's product of two sinusoids in the form sin A cos B. So what is sin A cos B can be written as sin A plus B plus sin A minus B whole divided by 2. Sin A plus B plus sin A minus B whole divided by 2. Okay. So let me use this and write down what is the signal F2T whole divided by 2. So 1 by 2 I write down outside only. Okay. Then sin A plus B. Okay. Sin A plus B. So when you add this, 2 pi by 5 plus 4 pi by 3t. Okay. Plus sin A minus B. Plus sin A minus B. 2 pi by 5 minus 4 pi by 3t. Okay. Sin A plus B plus sin A minus B whole divided by 2. Now this is going to be 1 by 2 sine of. So this should be how much? LCM will be 15. 6 plus 20. 26 pi divided by 15t. Let me recheck it. This is 6 and this is 20. 26 by 15. Correct. Plus sine. Now this will be how much? 6 minus 20. Minus 14, and sine minus theta will be minus sine theta. So this is going to become minus sine theta, and that is 14 pi by 15 into t. Okay, 6 minus 20 minus 14. Correct. Okay, this is what is the answer left. Again, addition, subtraction, some linear combination of two signals are there. Okay, some linear combination of two signals is there. Correct? Yes, Ramji, that is what we have applied. Okay, now once again, okay, what is the time period t1? Okay, let us say the time period of this part is t1, and that will be 2 pi upon 26 pi by 15. Solving, I will get pi here pi will be cancelled and you will be left with 15 going above and 2 cancelled with 26, so 15 by 13. What is the time period of the next part is 2 pi upon 14 pi by 15. Again 15 going above, pi cancelled, 2 by 14, 7 will be left. 15 by 7. Okay, now dear, what is the ratio? Okay, what is T1 upon T2? Okay, 15 by 13. T2 is 15 by 7. So 15 will cancel. 7 by 13. Okay, ratio of two integers. Rational. It is perfectly ratio of two integers, and which is rational. Which is rational. Done, Aji? This is definitely rational. Okay. Now if it is rational, okay, what is the time period? It is periodic. So what is the time period? Cross multiply 13t1, simple, 13t1 or 72, whatever you want to take, dear. Okay, 72. Okay, any of the cross multiplication. So if I take 13t1, 13 going there, answer is 15. Okay, so this time period should be 15. And that is what? Okay, there is only one choice left here, 1. Option number 1 in the list 2, and that is 15 units. Done. Okay. With this, match the following. You have checked 4 different questions. You have checked 4 different questions. You have checked 4 different questions. Okay. So now let us go to the next. Okay. Now let us go to the next. Yes, dear. Next one for you. Have a look into this next one for you. A periodic signal is given to you. Cos 1.2 pi t plus cos 2 pi t plus cos 2.8 pi t. What is the fundamental frequency of the signal? What is the fundamental frequency of the signal? What is the fundamental frequency of the signal? So now addition of 3 signals. Okay, no problem. Okay, what is the time period t1 here? Dekho. What is the time period t1? Okay, 2 pi upon 1.2 pi. Okay, that is 2 upon 1.2, or that is equal to, if you cancel, yes, it will be expressible as, if you cancel by 0.2, so 10 by 6. Okay, or 0.4 se cancel kare, this is 5 by 3. This is 5 by 3. Okay. What is the time period t2? Individually, every sinusoid is always periodic. So t2 is 2 pi upon 2 pi 1, and t3 is 2 pi upon 2.8 pi. Okay, and that's going to be 2 upon 2.8. Cancel again with 0.4. So this is 5 by 7. Okay, these are the individual time periods. Now you have x1t plus x2t. Let me write it like this. You have xt, which is x1t plus x2t plus x3t. Okay, now there are 2 ways. Okay, now there are 2 ways of dealing with this. Okay, what are the 2 ways? Number one, what is the combined time period? Okay, for x1 and x2, what is the combined time period? Suppose that combined time period is equal to t dash. What is the combined time period? Suppose that is t dash. Okay, but for that, first I have to check the ratio t1 by t2, whether x1 plus x2 is periodic. So what is t1 by t2? T1 is 5 by 3, T2 is 1. So 5 by 3 by 1 is 5 by 3, which is rational. Yes, no, this is rational. Okay, now this is rational. Okay, so the x1 plus x2, the addition of x1 plus x2 is periodic and having the period how much? Okay, 1 into T1. Okay, simply 1 into T1. Sorry, not 1 into T1, final ratio I have to take. I'm sorry. So this is 3 into T1 or 5 into T2. Okay, so T1 is 5 by 3, so 3T1 will be equal to 5. Okay, or 5T2 also 5. Anywhere, both of them will always give the same answer. Okay, so what is the time period T dash? Let me call it as T dash. The combined time period of x1 and x2 will be 5. Okay, now x1 plus x2 plus x3. Okay, so now what you are going to check? Okay, now you are going to add this periodic signal with another periodic signal. So again, the ratio of their time periods will be taken. So T dash upon T3. What is T dash is 5, and what is T3? Dear, that was 5 by 7. Okay, so 5 upon 5 by 7 is 7, like 7 by 1. Okay, ultimately this is also rational. Yes, this is also rational. So what is the final period? It is 1 into T dash, 1 into T dash or 7 T3. Okay, so 1 into T dash. What was T dash? 5. So that is the final period 5. So dear, what is the final period? It is 5. Okay, they are asking the frequency. I thought time period. The frequency is 1 upon, in hertz, 1 upon time period, that is 0.2 hertz. I thought it was time period, so I took accordingly. Okay. Now dear, what you can also do here is, if they are directly asking you the frequency, suppose, okay, what I told you, xt is equal to x1t plus x2t plus x3t. Okay, look into alternate. Look into alternate. Okay, what is the time period? It is LCM of T1, T2, T3. Okay, it is periodic because the ratio test is satisfied. Good evening, Sarah. It is periodic because the ratio test is satisfied. Okay, so what is the time period? LCM of T1, T2, T3. LCM of T1, T2, T3. That means it is LCM of T1, which was 5 by 3, I think. 5 by 3, 1 and 5 by 7. 1 and 5 by 7. Now, how do you calculate the LCM of fractions? It is equal to LCM of the numerators. It is equal to LCM of the numerators divided by the HCF of the denominators. The denominator of this automatically is 1. Okay, what is LCM of 5 and 5? It's just 5. 5 and 5 equal, and the LCM will be 5. Okay, HCF of 3, 1, 7. 3 and 7 are both prime numbers, so the common factor can be just 1. Okay, so the answer is 5. Answer is 5. Okay. Acha. Now this leads to one more case. Okay, the final time period, as I told you, is the LCM of T1, T2, T3. Acha. What is T1, T2, T3 in terms of frequency? 1 upon F1, 1 upon F2, 1 upon F3. Okay. Now, what is the LCM of this? As I told you, it is equal to LCM of numerators divided by HCF of denominators. Acha, LCM of 1, 1, 1 is simply 1. So, what you are left with only 1 upon HCF of the frequency. Okay, and then the time period, which is 1 upon frequency, overall 1 upon frequency is 1 upon HCF of the individual frequency. That means if directly you want to calculate frequency, what is the frequency? Okay, what is the frequency? It is given by HCF of F1, F2, F3. Okay, directly if you want to say what is the frequency, it is the HCF of F1, F2, F3. But dekho, this is anyways always the end calculation. Why I usually do not solve, my personal habit. Okay, good evening Rahul, thank you so much. My personal habit, why I do not usually solve with LCM or HCF. Reason is, see, that is the final period or frequency, but that can only be applied if the signal is periodic, na? If the signal is periodic, na, that can only be applied if the signal is periodic. Okay, let us go here. Okay, now how to check whether the signal is periodic? Ultimately, you have to apply the ratio test, T1 by T2. The ratio of period should be rational number. So now anyways, you have to check up to this, T1 by T2. Okay, 5 by 3 rational. So now you are safe. Now dear, anyways, if you have done this much calculation, so 5T1, how much time will it take? 5T1 is equal to 5. Why to again go for LCM or HCF calculation? That is the reason I don't usually prefer it, because you know, if I just tell you always use LCM, then you will start applying LCM without checking. No, the result, the linear combination of two periodic signals may not be always periodic. That is what we learned earlier, may not be always periodic. It may become aperiodic also. So that is why first you have to check T1 by T2, and if you are checking T1 by T2, then the next step is very simple, and then there is no additional need of going to LCM or HCF. Okay, there is no additional need of going to LCM or the HCF. Okay, chalo. So now there is something similar. Okay, something similar. Acha, will the DC component affect? Chalo, this is something similar. Homework number 1 for you. Okay, again today I'll give you 2 homeworks. This is something similar, homework number 1 for you. Okay, now addition of 3 signals. Okay, 1, 2, 3. So how to deal, just like previous question. Okay, now there is a constant DC added to it. Okay, before you understand the effect of constant, have a look into this example. Find the fundamental frequency and as well as the period of cos square 3t. So we know for cos omega t, cos square. Okay. That also ultimately is possible, Rahul. That also is ultimately possible. Chalo. That is eventually GCD or HCF only. Chalo, what is the, now if it is cos square, will it going to affect, okay, the frequency? Dekho, just use the cos square theta as 1 plus cos 2 theta. 1 plus cos 2 theta. So that becomes 1 plus cos 6t divided by 2. That means the signal xt is equal to 1 by 2 plus 1 by 2 cos 6t. Okay, now dear, this part, is it periodic or not? This is a cos omega t, so hence it is always periodic. This is a cos omega t and hence this is periodic. Okay, and what is this part? This part is the DC part. This part is the DC part. Okay, this is periodic, and with how much period? Okay, with the frequency 6 and the time period equal to 2 pi by 6, that is pi by 3. Okay, the angular frequency 6 and time period pi by 3. Will the addition of a DC term, a constant term, affect the period or frequency or the periodicity of the signal? No, actually not. See what actually is going to happen. What actually is going to happen here? See what is going to be the waveform. I'll just show you what is going to be the waveform. Okay, suppose let me take any signal A cos omega t. Okay, added with some constant k. See, if the constant was not there, how do you draw the cosine waveform? This is how we draw the cosine waveform. But there is a constant, okay, added. There is a constant k added, and that is what is the effect of this constant? Okay, every value of the signal, okay, for all values of time, it's going to be uplifted by some value k. It's going to be uplifted by some value k. Okay, that means the waveform is going to be still periodic. All the values are going to be uplifted. So see, maximum amplitude of cosine, dear, maximum amplitude of cosine was a, now it will become a plus k. The peak, the lowest value was minus a, now it is minus a plus k, that is also uplifted. But is there any effect on the periodicity? Okay, only the graph shifts upwards, correct. Okay, it is just an amplitude upgrade. Okay, all the values are added like we have learned in the basic operations class also, in the last previous classes. So this remains to be periodic only. Okay, periodic with same period. Okay, that is 2 pi by omega. This period remains to be same. The signal will be periodic with the period of what is the period of a cos omega t. So what is the omega here? 6. Okay, and hence the period is going to be pi by 3 only. The period is going to be pi by 3. Okay, chalo, so that is what one next homework I have given to you, where 3 signals have been added. Okay, where the 3 signals have been added. Okay, 3 signals have been added. So what is the final time period and frequency with respect to 3 signals? That is what we have just learned in the previous question. Now a DC is added. Will it affect the time period? No. So just discard this. This is not going to affect the time period or frequency, whatever the question is. That means whatever you have to calculate, you can quickly calculate from these 3 parts. You can quickly calculate from these 3 parts. Okay, quickly calculate from these 3 parts. Chalo. Yeah, that you can do quickly. Okay, chalo. So let's move ahead to the next. Okay, now this was homework number 1. This is homework number 2 for you. Intentionally I am giving you this question as homework. Okay, you can also try signal xn equal to sine of n square discrete time, because discrete time I will discuss in the next session. Okay, so dear, okay, I will discuss both of them. This homework will be discussed, okay, and I will discuss both of them, okay, but in the next session. I want you to try, okay, and I will explain you both together. Sine of t square, sine of n square. We know sine t is periodic. Okay, we know sine t is periodic. Sine 2t, sine 3t, sine 4t is periodic. But what about sine t square? Is it periodic? What about sine n square discrete domain? Is it periodic? Are both periodic in continuous domain also and discrete domain also? Okay, yeah, is there any twist in any one of them? Please try. We'll discuss both in the next class. Okay, that is of course Wednesday 9 p.m. Okay, Monday, Wednesday, Friday is what we are having the signal session. Okay, next question, dear. Chalo. Now MSQ question, multiple select question. If xt be a continuous signal, okay, continuous time signal, and let y1t equal to x of 2t, y2t is equal to x of t by 2. Okay, what is this x of 2t? We know that mod a greater than 1. X of at case mod a greater than 1. It is the case of compression. Okay, x of t by 2 mod a less than 1. It is the case of expansion. Compression and expansion. Dear, compression and expansion. Okay, will it affect the periodicity? And then there are 4 statements which you have to choose. So dear, I'll explain you. Okay, compression and expansion, will it affect the periodicity? Will the compression and expansion, okay, should they affect the periodicity? Okay, should they affect the periodicity? Just try to imagine in mind, you will get your answer, but I'll draw it for you. Just try to imagine, your answers will be there for you. Yes. Suppose I take a signal which is periodic with period of suppose 2, so that then I'll compress it. Suppose this is periodic with period 2. Time period equal to 2 means it should be sine of 2 pi by pi, sine pi t. It should be sine pi t. Suppose I take sine pi t, amplitude 1. Okay. Now, okay, suppose this is xt. So dear, if I ask you what is x of 2t, what is x of 2t? Replace t by 2t, it is sine 2 pi t. Is it still periodic or not? Dear, it is still periodic. Only difference is its period t, its new period t dash will be equal to how much? Will be equal to 2 pi by 2 pi, which is 1. Now, what is the period of this one? The period of this one I have taken as 2 unit. Okay, and what is this one? It is half of the previous. It is t by 2. Okay, with respect to the previous time period, it is t by 2. It is still going to be periodic. Only thing is period is going to be half. Why half? Because x2t is nothing but compression of the waveform. The waveform is compressed in the time. The nature of the waveform, the amplitudes of the waveform remain the same. It is compressed in the time domain. It is compressed. So if this was having the time period 2, it will be having the time period of 1. It will be having this time period which is equal to 1. Okay, this is how it is going to be. And similarly on the left hand side also. Acha, then what about x of t by 2? If you do x of t by 2, okay, so that is going to become sine of pi by 2t. But every sine omega t is periodic, na? Every sine omega t is periodic. What is its period? 2 pi upon pi by 2, that is 4 units. So period has been increased. With respect to the earlier one, the period was 2 and it can be written as 2t. Okay, the period is doubled as compared to the first case. Why? Because x of t by 2 we know is the expansion of the signal, expansion by a factor of 2. That is why when you expand the waveform, time period is also twice. Time period is also twice. So now the time period will be 4 units. Now the time periods will be 4 units. Okay, something of this kind. Okay, so whenever you compress or expand a signal, dear, I can simply put that if xt is periodic, okay, if xt is periodic, okay, with the period t, then x of at is also periodic. That is also periodic with how much period? With the period t by a actually. Okay, if it is like 2t, if it is 2t, so t by 2. If it is half of t, so t upon half, it will become 2t. So t upon a, yeah, t upon mod a. Sometimes a may be negative, that represents time folding, that will not affect the period. So t upon mod a. Right. Good evening, Driver. Yes, how are you also? Happy to see all of you here. ठीक है जी, done है. So, देखो, if xt is periodic, y1t is periodic, true. If xt is periodic, y2t is periodic. First and sorry, there is a shuffling I think in the names here. No problem. I will make it again A, B. This is C and D. The first and third to correct hai, because y1 and y2 is compression and expansion. Whether compression or expansion, any time scaling, will, not make the signal aperiodic. If it was periodic, it will remain to be periodic. Even what is the new time period, that also I have explained you. They are not asking the time period. Okay, but whether y1, y2 periodic, yes. Now let's think reverse. If y1t is periodic, what about xt? So can you write down xt in terms of y1t? If you want to write down xt, so write down t by 2. Okay, introduce t by 2 here. Okay, so you will have x of t equal to y1 of t by 2. Because when you write t by 2, here you get t by 2 and then 2 will cancel, xt. So xt is y1 t by 2. Okay, ठीक है. Similarly, in terms of y2, okay, देखो, y2t is x of t by 2. So if you write down 2t here, so 2t by 2, 2 will cancel. Okay, so what is xt? y2 of 2t. That is y2 of 2t. Clear? Chalo. Now, option number B says if y1 is periodic, y1 t by 2. Now, again, what is y1 t by 2? What is y1 t by 2? It is expansion of the y1 t. Okay, and expansion or compression will not change the periodicity of the signal. It will slightly change the time period, but it will not make the signal aperiodic. So, they are asking whether it is periodic. Yes. Okay, if y2t is periodic, xt is periodic, so xt is y2 2t, compressed waveform is also periodic. You just have to say yes or no periodic. Yes, it is periodic, and it was a MSQ question, and we have already discussed a lot of times MSQ, multiple select question, one or more than one can be correct. Okay, so here all are correct. Sometimes maybe one correct, maybe two, maybe three, maybe all four. So this is a MSQ question with all four options correct. This is a MSQ question with all the four options correct. Done it. So I have left you two homeworks for today, and I will definitely share you the PDF. As I have already told you that whoever is watching the session, they get the PDF. Okay, because the PDF is always password protected. So what is the password for today's session? Let me keep a simple password that clicks to my mind. It is period. Whatever just written here. Randomly I create the password. Okay, you get the PDF in my Telegram. I'll share you tomorrow morning. Okay, that will be password protected, having the password of period. Okay, chalo. So this is the password to access the PDF, and I hope you are connected in my Telegram. There you will get the PDF. Done it? Alright guys, all important updates for you that yes, if you are a GATE aspirant preparing for EC, okay, the online live batch, okay, at OHM Institute, the next online live batch starts from 1st June, just coming up very soon. Okay, the fees for GATE 25 is 29,999, but it is currently 19,999. Similarly, the GATE for 2026 currently is 28,999, and you get the complete conceptual clarity with all sort of best problems, more than 3,000 problems discussed within the live class. Okay, daily lecture notes with the topic wise handouts for your even more practice. Okay, topic wise PYQs with solution, doubt solving, separate sessions. Okay, and you can access it through laptop, tab, mobile, anywhere you can access. Okay, you can access from mobile app also. You can go to the desktop website also. Okay, the total course duration 5 to 6 months. Okay, and for EE with similar features and similar fees. Okay, the new batch for EE starts from 4th of June. Okay. Yes, Anil, I am also taking offline classes at home. Already I have completed one schedule there, and very soon I am coming to take signal and system in the offline batch. Okay, probably I think I am starting it from 31st of May, Friday. Okay, I'm very soon traveling to Hyderabad to take a signal and system offline batch. Okay, the offline batch signal and system. All right. Yeah, so that's just this week only. Probably Friday I am starting that signal and system offline batch. Alright guys, so summer short term, I'm sorry, this is a previous one only, but summer short term next batch starts, okay, on 30th of May. The new next summer term batch starts on the 30th of May. Okay, the fees for summer term short term, so the summer term course, okay, it's a course of 60 to 65 days for those, okay, who want to complete the entire syllabus in one shot and then dedicate their time to revision and test series. Okay, so complete course duration 60 to 65 days. Only thing is, because it's a short term course, so non-stop daily without any gap classes will be going on, and that too for approximately 9 to 10 hours daily. Little bit hectic, but yeah, good to cover up time and in less amount, good to cover up syllabus in less amount of time. Same syllabus in detail only, no compromise with the content. Okay, and then dedicate your time to revision and test series. And let me tell you that this is a batch very famous in Hyderabad, and lots of toppers of Hyderabad are probably from summer short-term courses. So, that is how the course is popular. There are several discounts that you're able to see, maybe for, IIT, NIT BIT student, 50% discount, okay, and etc. There are some discounts which are available on screen. You can clearly see, like if your rank is under 2000, in any of the previous years in ECEE, you again get 50% scholarship. If you're a previous student of any institute, online, offline, anywhere, 40% scholarship for you. And if you're IIIT or government college student, 30% off for you. The next regular, now if you don't want to go for the summer short term, the next regular, this one is regular offline batch that starts from 30th of May, whose fees will be 56,000 currently, and of course with some relaxations, as again mentioned here, that you can see, okay, some discounts for different categories of students. Now, if you want to know anything more about the batches, any more details about faculties, about the batches, timing, study material, anything, you get the study material also completely within these courses. Okay, so you can contact 95156 94053. I repeat, 95156 94053, or log into the website ohminstitute.com. Okay, and directly purchase the course from there. Chalo, this is Rakesh Sir signing off, guys. Now see you Wednesday, next session at 9 p.m. Discrete time periodic signals. Concept wise similar, but calculation wise you will see some differences. That is why I have separated it. So next class, discrete time periodic signals. Bye bye. Thank you. Stay safe and do take care of yourself.